Welcome back to our channel and back to the tutorial for computer organization architecture. Today we are going to continue the topic called that is data hazard. The previous session I explained about what is structural hazard and with example. Today we are going to see the hazards, that is data hazard with a simple example. So there will be three types of hazard is there. I already know the hazards also always disturb the performance of the pipeline, etc. So here, first of all, you know what is data hazard. Data hazard is nothing but happen when an instruction attempt to use a resource before it is ready. There are three types of data hazard. One is called read after write hazard, and another is write after read hazard. Another one is the write after write hazard. So we are going to see the solution. Two types of solution for resolve the hazard. That is the data hazard. Let's see the example for read after write hazard. See here, let's assume that there will be an example given. There are two instructions there. One is I, another called J. I instruction consists of a code called add R1, R2, R3, followed by J instruction consists of sub R4, R1, R6 here. So here now what is the meaning of this one? Okay. So here add the content of R2 plus add the content of R3 and store the result in R1. That is the meaning of this instruction. Next instruction is there, that is subtract the content of R6 from R1. That is the meaning of 1 and save the result in the R4. So for this, performing these two instructions concurrently, we need support of these 5 stages. That is called instruction fetch, another called instruction decode, another called operation fetch, another called execution phase, another one called the write back result phase. So generally, nothing is there means there will be a everything start from the clock cycle only. Clock cycle 1, clock cycle 2, and so on and so on. So just let's assume that we are starting the instruction that is I. Instruction fetch will start in the clock cycle 1 and instruction say in the clock cycle 2, instruction 2 that is J will be start execute, and similarly in the clock cycle of 2 instruction decode also started. That means it take the operand of add, and similarly in the clock cycle 3 it takes the operand of sub from the second instruction here. Then operation fetch is there. When come to the clock cycle 3, the operands are fetched, that is R2 R3, because later we are going to perform that addition operation, that is add the result of add the value of content of R2 plus R3, then save in the R1. So here simultaneously operation fetch of R1 R6, that means subtraction of R6 from R1 also started here. Then next execution state in the clock cycle of 4, it allow for the next execute the instruction, that is perform the operation of R2 plus R3, then save the result in R1. That's the overall result. That total result will be saved in the R1 only. Now there will be a data instances happen. Why means here after this the execution phase, next it go for do this perform the operation, that is R6 minus R1. Add the subtract the content of R6 from the R1. So generally create the R1 what data inconsistency. Why? Because here the R1 value is here different. There is a old value, it won't consider. So the data inconsistency consider here. Let's go for the solution with delaying pipeline and one more called the operation forwarding. So here first one is the idea is what delay the pipeline, that is delay the execution of operand fetch till the result gets stored in the register, which the cause of inconsistency. Let's see the example you understand. Here let's assume that we are taking the same example of simultaneously or concurrently execute the two instructions. So clock cycle 1 I will be started, clock cycle 2 what J will be started, and instruction decode the cycle 2 R will be there and subtract here, and after performing this addition operation the fetch phase, no, we are going to create a delay of two things, that is clock cycle delay 4 and clock cycle 5 here. Then you give the chance for next instruction, that is R1 R6. Here once the R2 plus R3 performed, the value will be stored in R1. Okay. Then after once updated value in the R1, then you consider for the execution of next instruction. So we can make delay and give the chance for instruction one by one. That is the concept of delay the pipeline. Then go for the operation forward. It's also simple and easy only. And before that we have now one point. So inconsistency one point is there, go through later. So operation forwarding idea is what? Forward the result of execution unit of first instruction to the operand fetch unit of the second instruction. So from where it can be read by the required instruction as their operand. So let's see the example from the previous one. So here, so let's assume that the same we are taking the two instructions, that is clock cycle 1 taking the I, clock cycle 2 concurrently take the J. Then it instruction decode phase R will performed, and in cycle 3 subtraction performed. Then we the addition operation fetch point, it take the operand of R2 R3 and start to perform the addition operation. Then we are creating only one delay. Okay, we are making one delay. Then the operation performed here, that is R2 R plus 3. The result then this will be forward to the, that is called operand for forward to the next clock cycle, that is a 5 cycle. So remember, before we are used before concept we made two delay, that is two clocks delay, but here only one time. So here we are just forwarding, then the R2 plus R3 will be added, the result will be stored in the R1. Then at last whatever the R4 is R6, then the content of R6 will be, the contents of R6 will be deducted from R1. At last result will be stored in the R4 here. So like that we can find the solution for data hazards. So I hope that understand the video. If you like the video, please subscribe, share with your friends. Thank you for watching the video. Thank you.